What is up? Welcome back to another Unreal Engine course, and this time we have a really cool. Let's just see the game that we're going to create. So if I hit the play button, we have a nice ball, we have a nice glowy effect, we can move the ball left and right, we can jump with the ball. So this laser over here is going to kill us. Pay attention at the top left corner for our energy, bam, is being drained, as you can see. We can interact with these cubes, so I can, like push it or drag it towards me like this, and I can jump from one wall to another like Spider-Man over here. And of course, we're going to learn how to do all of this. We do need to drag this other cube so that we can prevent these other lasers from killing us. And there you go. Now we can jump on the elevator, click on the E button to interact, and when we jump off the elevator, it goes down. And no, now we cannot reach the top. What we can do? Well, we can jump and interact with this cube. There you go. So we can do that as well. Bam, there you go. And we can jump over here, and voila, we reach the top. Of course, this project, you will have assignments in it. That's the beauty of it. So I will give you assignments to finish the game, and you can add new features because this serves like a template that you can use to build upon. So you can add new features, and that way you can learn, and so on and so forth. Now, even though this looks like some simple game, believe me, you're going to learn a lot of cool things because a lot of interesting things went into creating this project. So again, just go through it. You will have assignments to finish it because I will show you how you can rearrange these rocks to create other levels, to add new features, more obstacles, so on and so forth. Again, while my channel is still not dying and I'm not asking for help, just share the video, like it, subscribe, and comment below. It helps the algorithm so this channel can grow. So yeah, we're all a community over here, so be part of a community, like share it, so other people can benefit and you help me as well, so it's a win-win situation. Anyways, thank you, thank you for watching this video, and stay out of jail, I guess, man, because you cannot watch this video if you're in jail. Take care and enjoy the rest of the tutorial. So now that we saw the game that we're going to create, let us actually create the game. So over here, I have the Unreal Engine project browser. You know what it is. So we're going to click here on the games and then click on next over here. We want a blank project. From here, click on next. Blueprint is fine. We don't need the starter content, so you can either do it with or without, but essentially we don't need it. Everything over here can be as is. Now over here, as you already know, is where you're going to store the project, so make sure that you set that to your desired location. And over here is the name of your project, so we are going to call it Platformer. There you go. And I'm going to click on create the project, and voila, we are going to wait probably a gazillion years. And I think that I will need to cut out the video. So yeah, see you when this finishes. And finally, we are here. It didn't take that long, but I still had to cut it out because you will probably be mad and be like, oh, blah, blah, blah. And I'm not gonna go further into that. Just kidding. But anyways, the next step for us is to click here on the content, right click that is, and show in Explorer. There you go. So this is where we are going to put the assets, and the assets are right here. So these are the assets. You can download them. Link will be below this video. So just, scroll down below the video and you will see a link where you can download the assets. And what you're going to do is copy all of these. So copy all of the assets, everything that you see in this asset folder. And over here, again, right click here on the content, show in Explorer, and it will open this bad boy for you. Right click and paste the assets. So when you paste the assets, we are good to go. Now, when we go here in the maps and click on the example map, voila, this is our map. Now, again, these are all, as you can see, separate items that you can put together in order to create the level. And what I'm also going to do is here inside of the outliner, so world outliner, which is on the right, I am going to right click over here and create a folder, and this is going to be level parts, or however you're going to call them. And I'm going to select all these rocks, and I am going to put them inside of the level parts folder, just so that we can organize them a little bit and we don't have, everything clustered inside of the world outliner. Anyways, what's good about this is that you can always, you can move these things around to create new levels, yada, yada, yada. It serves like a template and stuff like that. So, for the assignments that I will give you later on to create new levels, you can do that on your own. So basically that's that. Anyways, the next step for us is to go and create our ball player. So let's go over here in the blueprints, which is currently empty. I'm going to right click and we are going to create a blueprint class, and this class is going to inherit from the character. Now, as you can see here, characters are pawns that have a mesh, blah, 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 blah. Click on that, and this is going to be BP underscore player ball. So player underscore ball, or you can put that everything, you can put that all together. It's up to you, you know. It's not important, and I don't care, you know. I don't care what you do, okay? It's your life. You can do whatever you want. But anyways, just kidding. What you need to do, or what we are going to do now, is that we are going to add a mesh and all the good stuff. Now, first things first, we are going to attach or add a static, or actually, yeah, a static mesh component. So let's go over here, click on add component and filter for static mesh component. Here it is. This is the bad boy. As you can see, this is the skeletal mesh. We don't want that. We want this one, static mesh component. Now for the static mesh, click here, as you can see where it says the static mesh, click there and filter for the ball. So click ball and SM ball. Here it is. So click on that one and there you go. This is our ball. It's, you know, very funny. Now over here for the elements, we are going to search for the ball element. So click here, ball, filter for the ball, and there you go. It looks like a golf ball, you know? It looks like a golf ball. So we're going to say it's a golf ball. Anyways, what we are also going to do is we are going to scale it. So over here in the transform for the scale, click on the lock icon, and we are going to say 1.5 for the scale to rescale the ball so it gets a little bit, you know, larger. Also for our capsule component, what we are going to do over here is the half height, and the radius are going to be 75 for the half height. Radius is going to be also 75. So as you can see now, the whole ball is covered in the radius of the capsule component. Make sure that you compile and save that. What I am also going to do is I'm going to attach a spring arm. So click here on add component and filter for the spring arm. Now, if you don't know what is a spring arm, basically it's a holder for the camera. So you can think of a spring arm as a holder for the camera. What we are going to do for the spring arm is over here for the rotation on the Z axis, we are going to say -90. There you go. And we are also going to set the target arm length. So this over here in the camera, it's currently at 300. We're going to set it at 1536, so 1536, which is going to make that a little bit further away from the ball. There you go. When it comes to the target offset for the Z-axis, we are going to set that at 300. There you go. And basically, as you can see, it's right over here, like in a diagonal way with an angle. It's looking at that ball. So basically that's that. Do collision test over here. We don't need this. So if true, do a collision test using probe channel, probe size. You know, we don't need this. We don't need this. So compile and save that. And the next step for us is selecting the spring arm and attaching the camera. So click on the camera and there you go. So now we have the camera on it. When it comes to the camera, we are basically not going to touch anything. We don't need to touch anything because we have everything set up within the spring arm. Now make sure that you compile and save that. If I were to go over here in the example map and hit on play button, and over here, just 1 second, we do have, because I prepared this project and some of the things that we do need to delete, what we need to do is go here while you're in the example map level, click on the, you see over here where it says blueprints, click on the drop down list and click here open level blueprint. When you click on that, just delete these two nodes. So just delete these two, compile and save that. This is later on for creating the UI for the game. So when we have our UI, we will have this over here or somewhere else. It's not important, but that is for the UI. If I hit the play button now, everything is cool. But you see this over here, we don't have our ball, we don't have anything. So what we need to do is go back here in the content browser inside of the blueprints and right click and create a blueprint class. And from here, from all classes in the search, we are going to filter for game mode. and we want this one, game mode. So make sure that you select the game mode, click on select, and this is going to be BP underscore platformer underscore game mode. So this is our platformer game mode. We only need it for one reason, and that is to go inside of the project settings and click here maps and modes. And over here at the top where it says default game mode, we're not going to set the game mode base. Instead, we're going to say the platformer game mode, the one that we have just created, which now enables us to edit the default pawn class, which is actually the player. So from the default pawn class, we're going to select the BP player ball, which means now when we go here in our example map, let me just close the example map blueprint. Over here, as you can see, I have already prepared from this level. This is the player start, or where the player is going to be spawned when we run our game. So if I hit play now, there you go. We have the ball, and this is because we created the game mode base and we attached it over here, and we set the player ball to be the default pawn class. And now when we, run the game, it is being spawned. Moving forward, let us go back inside of our player ball. And what we are going to do first is create the variables that we need. So the first variable is going to be our ball material instance like this. Now I am going to just declare all of these, then I'm going to set the types and whatnot. Next we have the move direction. Next, we are going to have over here flat velocity. And what did I type over here? So it's flat velocity. There you go. Click on the plus. And again, here we have the current speed. Moving forward, we have the rotation amount. So rotation amount. Moving forward, we have the ball rotation rate. Moving forward, we have the power. We have the energy, so energy, and is dead, and last but not least, we're going to have the HUD reference. So click here, compile and save, and what we are going to do. Well, first things first, we are going to set the ball material instance. You can either click here, so you can either click here on this little icon, the red one, because currently all of these variables are booleans. And you can either click there, where I'm currently pointing with this arrow, or you can click on here, variable type, which is in the details tab on the right side. And from there, you can click here on the search, and you're going to search for material, and you want a dynamic material instance. Let me just find it over here. Actually, is it dynamic or just material? Let me just see over here. So it's dynamic material. Yeah, here it is. Material instance dynamic. This is what we want. And you're going to click on this object reference. This is what we need. So material instance dynamic. Move direction is going to be a vector. So click on the button to choose a variable type, and move direction is going to be a vector. Flat velocity is also going to be a vector. So click on the button to change the type of the variable. The current speed is going to be a float. So click on the button and select float. The rotation amount, same, is going to be a float. So click on there. The ball rotation rate is also going to be a float. But for the ball rotation rate, we are going to set the default value. So the default value for the ball rotation rate is going to be 0.75. And you can set the value over here where I have just drawn. Now, moving forward, we are going to have our power and energy. Both of these are going to be floats. So float here, energy is also a float. Make sure that you compile and save that. And over here, the value for these both are going to be 100. So 100 for the energy, 100 for the power. Is going to be a boolean, and we're going to leave it as is. Here for the energy and power, make them publicly available, and also for our puzzle mode. So we have one more variable, which is going to be our puzzle mode, and I am going to move it over here and put it right directly below the material instance. So let me just change the order, even though the order doesn't matter, but hey. So here I'm going to say puzzle mode. There you go. Click on the button over here, and we are going to set this to be a boolean, compile and save this bad boy. And also the puzzle mode, just set it over here to be a public one. Now, this is for the variables that we are going to use. Moving forward, what we are going to do. we are going to first create our event. So I can remove this from here. We will need this later on. But over here, right click, and for the node, we are going to search for a custom event. Custom event is the one that we created. It's not already defined. We are going to define it right now. So I'm going to call this bad boy enable disable input, and this is going to allow us to either enable and disable the input. Now, one thing, when you click on this over here, you can have these inputs, which are basically parameters. So I can click on over here for the plus button and add a new parameter, and over here the parameter is going to be a boolean and the name is going to be enable. So there you go. And now we have a boolean parameter over here. So what's going to happen here is that we are going to go in a branch, and the branch is an if-else statement. And the condition that we're going to test is this enable. So enable is the condition that we're going to test. It's either true or false. If it's true, we're going to enable the input. But before that, we are going to get the player controller, because the player controller is the one who can enable and disable the input. So over here, I can say enable input, like this, and right click over here, I can say disable input. Now this is going to enable and disable the input on the player controller, which means it will disable the input on our ball. There you go. So if it's true, we are going to enable the input, and I'm going to click on this and I'm going to position it like this. And if it's false, we are going to disable the input, because the parameter is enable. If enable is true, then we're going to enable the input. If it's false, we are going to disable the input. Pretty straightforward. Here I'm going to create a comment section. I'm going to call this bad boy enable / disable input. And if you didn't see how I created a comment section, basically what you need to do is just, hover or select with your mouse like this by dragging your left mouse. Select all the nodes that you want to group in a comment, then right click and go over here, create comment from section. And of course you can select this comment, you can delete it and it can go away. So if I select it now and hit delete, it will be deleted and go away. Over here, everything is straightforward. I don't think there is no extra explanation for this, or if there is, just, let me know in the comment below the video. Anyways, moving forward, we want another custom event. So let's go over here and right click, and we are going to filter for custom event. And we're going to add here a custom event, and we are going to call this one change ball material instance. So the name of this bad boy is going to be, just double click it over here again. Okay, here it is. Change ball material instance. There you go. Now this, actually, excuse me, it's change ball material color, not instance, color. So change ball material color. Now this bad boy has two parameters. Click on him and inputs, click +2 times. The first one is going to be the param name. So here we're going to say param name, and the type over here is actually going to be the name. So name is going to be the parameter. And over here, we are going to have a value float. So here we're going to say value, and there you go. So compile and save that. Again, as you can see, we have two parameters. One is the name and other is the value. What we are going to do is we are going to get the ball material instance. So we are going to get it, which is the one over here that we have. As you can see, here is the bad boy. What we are going to do now, we are going to drag from here a node, and we're going to say set scalar param value. Basically, this is going to change the value of the parameter. So over here, we're going to plug this in. So this goes over here. Next, we're going to plug in the parameter name over here, and the value will be plugged over here. And after that, we are going to get the ball mesh. So here we have the static mesh, and I need to change the name to the ball mesh. I mean, it's not important, but for our references, it is better to know. So this is a ball mesh, and we are going to say over here set material. There you go, not this. So from here, set material, and we want this one. So set material, there you go. Plug this in over here. This goes over here. And last but not least, we want the material, which is the ball material instance. So here, get the ball material instance and plug it in, and there you go. Compile and save that. Now what I'm going to do is select this, and again right click and create a comment from section. There's going to be change ball material color, and make sure that you compile and save this. What is this essentially? What is this going to do? Well, basically, if I go over here and select the ball material, and you see here we have the ball material. If I click on it, this is that material. And let me just open it. So over here is the material. Now, I'm not going to go into this because this is a separate topic on its own, dragging these materials, creating them with the nodes and whatnot. But over here, we have some parameters like power, like is active, and so on and so forth that control certain aspects of that material. As you can see, we then have the divide, then put it in the lerp and the multiply. And basically, as I said, this is a separate topic on its own. I will probably create a separate video just talking about how to create materials, how to do this and that with them. But essentially, what you need to know for this tutorial is that these parameters like power, is active, and so on and so forth, they control the colors of this material. So over here now, when we call this change ball material color, the parameter value is going to be one of these parameters, such as power, such as is active. So we're going to put that in the name over here, and the value is going to be, well, basically the value 1, 2, 3. It doesn't matter, but the value of the number. Now, what we need to do in order to make this work is go over here in the begin play, and I'm going to move it a little bit up over here. The first thing that we need to do is we need to get the material of the from the ball. So here from the event begin play, we're going to drag a node that we're going to call set ball material instance. Oh, actually, excuse me, first we need to create that. So let me just get the ball mesh first, get the ball mesh, and from here, get the material. So get the ball mesh first, and then get the ball material from the mesh. And from the mesh, we are going to create dynamic material instance. There you go. And we're going to plug this in over here. Actually, let me just do it like this. Create dynamic material instance. There you go. And the target is going to be capsule mesh, ball mesh. Let me just take a look at this. What is this over here? So it's not giving me, the target is primitive component. Kismet library. Let me just go over here. Create dynamic material. We want the one from the, well, all of these are from Kismet. No, we want the first one. Create dynamic material instance. This is the one that we want. So you can get confused sometimes with these because, as you can see, create dynamic material instance. You see, we have, a couple of these functions. So we want the first one, create dynamic material instance, and we want to plug in the parent over here, and it goes right there. So the next part, and we can move this closer because I'm going to create a comment from this. The next part is to set the ball material instance. There you go. And we want to set it to this return value that we have over here. See, returns value material instance dynamic object reference. So we can set that to this over here. Now I'm going to select these, and I'm going to right click and create a comment section. And what's going to happen here, first I'm going to say first set the material instance, the material instance. There you go. And we can move this from here. So you can move the begin play a little bit outside. It's not important, but just so. So something like this. There you go. Maybe a little bit up because later on we are going to plug things here in the tick event. So we got the material instance. What is the next step? The next step over here is to first enable disable input. So we are going to say enable disable input. And over here we have the parameter. We're going to leave it false. As you can see or know already, if it's false, we're going to disable the input. So we're not going to allow the character to move. So disable the input. After that, we're going to say change ball material color. The parameter name that we are going to pass is going to be is active. And notice here, is active, capital I, capital A. The value over here, or the name that we pass over here as a parameter, needs to match up with the name over here. As you can see, this is the name of that is active. So is active, you can click on it and you can copy the name, and you can then go back over here and paste it just to be sure, like that. The value is going to be 0. So we're going to leave the value at 0. And now we are going to delay. So we're going to call delay over here, and we are going to delay for 5 seconds. So half a second we are going to delay. And after that, copy this and paste it. And again, we're going to call change material color for is active, but this time we are going to set the value to be equal to 1 and compile and save that. So let me just go back, compile and save that. There you go. I don't know if I didn't test it like this, but let me just try it out to see if this will work. Yeah, you see? So yeah, there you go. As you can see, of course, we are going to change another color. So we're going to change another color, but for that, we also need to create a timeline. So don't worry about that. We will do that in a moment. But as you can see already, we are changing the color. So first things first, and let me just stop this. First things first, we are setting the value to 0, waiting half a second, and then setting the value back to 1. As you can see now, how the color goes, as you can see, to the red color. So this is essentially what a small effect, not important for the game, but it gives a little bit crispy effect to the game, like, you know, it makes it look a little bit better. Going back inside of the player ball blueprint, next we need to create a timeline. So in order to create a timeline, we simply right click and simply type timeline like this, and here it is. At the bottom, add timeline. And we're going to call it ball activation timeline. And what is a timeline basically? Well, first we're going to drag a node over here to play. And a timeline allows, as you can see over here, timeline node allows values to be keyframed over time. How does that work? We'll double click on the timeline over here. And as you can see, we have values. So you have a float value, you have a vector value, you have a color track, you have an event track. We are going to click on the float track. And for the float track, you can, give it a name, whichever name you want. I don't know, value, simply type value. It's not important, or float track or whatever. We also are going to set the length over here to 1. So we're going to have a 1 length, and you can right click. So let me just compile and save that. So you can right click and you can click add keyframe, and you can click on this keyframe. And for the time over here, we're going to set it at 0 and value is 0. Right click and add another keyframe, and the value for this keyframe is going to be 1, 1. So basically the time, so when you click on it, the time is going to be 1, the value is going to be 1. This basically means it will go, or this float will go from 0 to 1 in the time of 1. This is basically what is a timeline. So the value of this float will go from 0 to 1 in length is 1 second, basically. So this is what we are doing over here. So if we go back over here in this time graph, from the update, and what does this update in the timeline? Basically the time it will take for that float to go from the specified value, which is 0, to the goal value, which is 1. So while that is happening, this update will be called. And when that happens, from here, we're going to say change ball material color. There you go. So change ball material color. Now, the material color is going to be, from here, I'm going to take the power. So get the power. And we're going to lerp. So I'm going to right click and I'm going to say lerp. And we want the lerp to be from a float. So not vector. So power. Let me just see over here. Lerp. Here it is. This is the one that we want. And I'm going to break it from here. Let me just move this a little bit over here so that it is more readable. So what's going to happen over here, this is going to lerp from A, which is 0, to the power. Value of the power is 100. If you remember over here, if you select the power, we set the default value to be 100. Alpha over here is the time. So the time it will take to go from 0 to 100, and basically that time is going to be the value over here from the timeline. And we're going to set the return value over here. We're going to plug it in, and the parameter value is going to be the power. So the power, compile and save, if we go over here, we will see that we have a power parameter which is controlling the colors. Next, when we finished, so over here when we finish, we're going to call enable disable input. So over here when we finished, we're going to call this enable is going to be checked. So now we will be able to, basically we will be able to move. So compile and save that. Again, what is happening? So over here, everything that we did explain. So let me just select all of this, create a comment group, and over here for the comments, so double click it, we are going to say change the color of the ball. There you go. So compile and save this bad boy. So again, from here, we are getting the material instance. We explained this. From here, we're disabling the input. We explained that custom event that we have created. Change the ball material color. We have it over here. So it will change the ball material instance, the color name over here, and the parameter name over here actually, and it will set the default value. Then it will set that material to the ball meshes material. So over here, we are changing the material color for isActive to 0, waiting half a second, then setting the material color for the isActive parameter to 1, then calling a timeline that will create a value, this float value, that will go from 0 to 1 in the time interval that we have already explained, and then we are going to use that in the lerp function, and lerp will slowly go from this value to this value over here in this time interval. So it will go from 0 to power, which is 100 in the alpha time, and then we are going to set that value for the power parameter. When everything finishes, we are going to enable the input. So compile and save that, and if we go back over here in our editor, and if I hit play, pay attention now. You see how the colors have changed. So again, stop and then click pause. Bam, it goes from no color to red color to green color. Now, of course, you can change or you can play with the parameter values to extend the length so that you can clearly or more clearly see if you don't see the changes of the color for some reason. So you can also extend the value of the time it takes to do that, but you know, I'm leaving up to you for you to experiment and yada, 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 basically. So yeah, let's move forward. The next thing that we are going to do is create the ball movement. And before we start to code that or blueprint that, we need to go here in our project settings. And for the input over here, we need to create our axis mappings and action mapping. So click on the plus button over here. So this one is going to be our first action mapping, and we're going to have a second one. And click on the plus button over here for the axis mappings. So first things first, over here for our action one, we're going to have jump. And for the jump, we are going to filter here in the search bar for the space bar. So space bar, when we press on our keyboard, we are going to jump. The next one over here, I'm going to call action. And action is going to be executed when we press the E button on our keyboard. So let me just find it over here. There you go. So when we press the E button on our keyboard, and we will be able to move the elevator upwards as we saw in the preview of this game. And we will be also able to move those boxes as well so that they can come closer to us and so on and so forth. This will happen when we press the E button. Now over here for our axes, we are going to say move right. This is going to be the name of the axes. And now over here, not pressing this plus button, but pressing this plus button to add another input. So basically, click here, and the first one is going to be keyboard or key code A, and the next one is going to be key code D. For the key code A, we're also going to add here minus. And there you go. So this basically means when we press the A or the D key, we will trigger this move right axis mappings. Now, what is this A and D? Basically moving left and right. -1 is for A because negative side, left side basically is the negative side. That's why we add here -1. So now we can go in our ball player blueprint, and right here below this change ball material color, we are going to create another custom event. So right click over here, custom event, and this one is going to be movement update or movement, however you want to call it. It's not that important, but it's important that you know what it is. So over here, we're going to go in a branch, which is an if-else statement. And basically, it will be true or false. And the condition over here is going to be our puzzle mode. So I'm going to plug it in over here. And if it's true, we are going to move our ball in one way. If it's false, we are going to move it another way. So first over here, I'm going to right click and we are going to say set move direction like this. And what's going to happen over here from the true, I'm going to drag it and I'm going to click on this line for the note 2 times so that I can add another input over here so that I can, as you can see, I can visually set it or make it more clearer to read. Clearer now is a word. Anyways, now over here, we are going to say get move right. And from the move right, we are going to make a vector. So I'm going to say make vector. And that vector is going to go inside of the x-axis. And I'm going to plug it in over here. And this is basically, we can move this a little bit up just to make it a little bit more clear to read. And let me just move it a little bit down like this so that it doesn't come close to this and doesn't obscure it, yada, yada, yada. Anyways, the next thing, if it's false, I'm going to right click. And from here, again, we're going to say set move direction like this. And the false one will go inside over here. And I'm going to double click it again and move it down like this and move this like this over here. So if it's false, we are going to calculate it like this. We are first going to get, and actually I can move it up here because we are going to calculate it over here. We're going to say get actor forward vector like this. So we're going to get the actor's forward vector, and we're also going to get the move right, get move right. And we are going to multiply these two. So we're going to say from here, multiply by float. So we're going to multiply this vector by this float. And from there, we are going to normalize this vector. So normalize. And from there, we are going to plug in this vector over here. And if I hover over, it will say for the normalize, if you don't know what it is, gets a normalized unit copy of the vector, ensuring it is safe to do so based on the length. Returns 0 vector if vector length is too small to safely normalize. Basically, what normalize will do, it will stabilize the vector, so to say. It will stabilize it, and it will make the movement a little bit smoother. That's the best how I can explain it in understandable terms. So after that, what we are going to do, let me just move this a little bit here, move this a little bit here like this. I mean, it's readable, so everything is readable. Next, what we are going to do is from here, we're going to say add movement input. And from there, I'm going to plug this in like this over here. So go from here, there you go. I'm going to double click this to create a new line over here and plug this one here as well. So there we go. So now both of these are connected to this one. And lastly, this one leads to over here, which means basically both of these are leading the execution order to the add movement input. Now, the last thing that we need to do is get the move direction. So we need to get it and we need to normalize it. So normalize. And now that we have normalized the move direction, we can plug it in over here, and there you go. So compile and save that. Basically, again, what we are doing based on the puzzle mode, if it's true, get the move right, make a vector out of it over here, which is basically going to create a vector with the value for the x that we have over here, which is either 1 or -1, because over here, you see, we have -1 or 1, and all other values are going to be 0. And then we're going to set that to the move direction. Over here, if it's false, then we're going to get the actor forward vector, then get the move right, multiply these two, and from there, normalize the vector and plug it into the move direction. And over here, then we're going to add that move direction normalized to the add movement input, which is going to move our ball or character. And I'm going to right click on this, create a comment from section, and this one is going to be move update. There you go. And you can compile and save this. Now, the last thing that we need to do in order to make this work, to run it, let me just move these comments or these sections over here and probably move this a little bit up over here, because now over here in the tick event is where we are going to call the movement update. There you go. Because the tick event is called every frame. Basically, it's like update in Unity. So compile and save that, and it will call every frame this event, or you can think of it as a function as well, and it will execute all the code that we have just explained. So now we can go back over here in our example map, and if I hit the play button, and now you will see that the ball is moving. Of course, we cannot jump and the ball is not rotating, so the next step will be to create that. But the ball, as you can see, can move left and it can move right as well. And we're moving left by pressing A key and moving right by pressing D key. In the case of, because this is a 2.5D platformer, we are moving forward and backwards. backwards by pressing A, forward by pressing D. You get the point, yada, yada, yada. If something is not clear, make sure to ask in the comment below so that I can explain this before you proceed to create other things that we are going to do right now. Moving forward, the next step is to go back in our player ball, and now that we are moving, let us rotate the ball. And we're going to do that right below the movement update. So I'm going to right click over here and create another custom event. And over here, I'm going to rename this one to rotate ball or something like that, just so that you know that this is used for rotating the balls. And also you can think of these custom events something similar like a function. I already mentioned that because you can basically create them like this. You can call them over here. Of course, we can, as you can see over here, we have this place a new node, but basically this can allow us to have a delegate on this event, but I'm not going to go into that right now. We will do that in another video. Anyways, what we are going to do from the rotate ball. First thing, from here, I'm going to drag a node and I'm going to set the flat velocity. And what we are going to set in the flat velocity? Well, first over here, I'm going to say get the velocity. So velocity, and we are going to get that from here. Target is the actor. Then we are going to break this vector into pieces so that we can have separate X, Y, and Z. And from there, we are going to make a vector. So from here, I'm going to say make vector, which will create a new vector that will allow us to plug in X, Y, and Z. So we're going to plug in the X, we're going to plug in the Y, we're not going to plug in the Z because we are not moving. So we're not moving the ball like this, we're moving it forward and backwards. So we're not going to plug in the Z, and we are going to plug this bad boy over here. So this is, let me just move these a little bit, and this one over here, so that we have, like a better visual representation of the node, because these nodes can get a little bit tricky if you have too much of these. They can get messy and so on and so forth. Same as like spaghetti code, you can have spaghetti nodes, so you need to be careful about that. Anyways, moving forward from here, we're going to set the current speed. And for the current speed, we are going to set the length of this vector. So length, and from here, we are going to say vector length. Here it is. So select the vector length and plug it. I almost said pug it. Plug it in over here. As you can see, the vector length is basically this. Think of it as a vector. Vector is like A, X, Y, and Z. So X, Y, and Z. The length of the vector is, we will use the length of this line, length of this line, and length of this line. So it will, like form a single line out of these three. So that is the length of the vector. So let me just compile and save this. So now that we have the current speed, we are going to go in a branch. So from here, create a branch, which we already know is an if-else statement. And we're going to test the current speed. So we're going to get it, and we are going to test if the current speed is not equal to. So it's not equal to. Notice I'm using the exclamation mark, and over here, it will make it not equal to, and we are testing it if it's not equal to 0, basically meaning that we are actually moving. So if it's not equal to 0, that means we are moving. And if that is the case, so if it's true, if it's false, we're not going to do anything. But if it's true, then we are going to set the rotation amount. And the rotation amount is going to be calculated like this. First, we're going to get the flat velocity. So get flat velocity that we set over here. So this is our flat velocity. Then from the flat velocity, we are going to get the vector length. So it's length, and I have issues spelling length, apparently. So get the vector length from the flat velocity. And after that, we are going to divide that by a float. So over here, divided by a float. And what is that float? Well, the float is going to be the ball rotation rate. So ball rotation rate. So get the ball rotation rate. We know that we set the ball rotation rate over here to be 0.75, excuse me. So there you go. Now we are also going to get the pi. So simply type pi, and I believe it's in the Kismet library. So let me just find it over here, not pinned, debug. Sometimes it's hard to find things that you need. So collision, not collision. Where is it? here it is, get pi, here it is. So returns the value of pi. And for the pi, we're going to multiply that. So multiply with the float, and the float is going to be the ball rotation rate. And from there, we are going to plug this into over here. Now, the next step that we are going to do is from here, we are going to go and multiply this. So multiply with a float, and the float that we're going to multiply is going to be get world delta seconds. And we're going to plug this in bad boy over here. And moving from there, we are going to add that. So add a float, and not like here, break the link, but here, add the float. And over here, get the rotation amount, plug it in over here, and plug this in over here. Now, of course, we are not done. We have still too many things to do. I mean, too many things, just a couple of things, but going back over here. Now, this is one of the things that I want to talk about. Now, to be completely honest, going into detail how this works and what this is, I have no idea. But, if you search online how to rotate a character, how to rotate a pawn, how to calculations to do that, you will find many different solutions. And you just plug in, sometimes I just plug in the solution and it works. This is just to show you that, you don't have to know everything. I don't know behind the scenes how this calculation works. This is some, I'm not going to say complex math, but if you are into math a little bit more, you'll probably understand this, how or why we are using, or how we are using the vector length of the flat velocity, dividing that by the p multiplied with the ball rotation rate, and then multiplying that with the world delta seconds. This is everything to smooth things out. We can basically rotate the ball by just using get world delta seconds, multiplying that with the ball rotation rate. And it will work. You will probably be able to rotate the ball just by using that. So multiplying the get world delta seconds with the ball rotation rate and adding that to the rotation amount. And that will turn out just fine. But these extra calculations are just to smooth things out. But as I said, like, the math that goes behind this, I don't know completely. So just to be honest, so we are going to leave it like here. If somebody knows, he will explain in more depth. But this is just to show you that you don't need to know every single thing and every single aspect about game development in order for you to be a game developer. So you can, just find some solutions online. If they work for you, they work. Great. Then you can just proceed, further in your game. So what we are going to do next is we are going to take the ball mesh, and from the ball mesh, we're going to say set world rotation like this, and move this a little bit here and plug this in over here. So what's going to happen here, or the rotation that we are going to use, is we are going to get the flat velocity, get flat velocity, and from it, we are going to make a rotation from its x. So basically from the x-axis of the flat velocity, and sometimes, I don't know why it's a but anyways, so we are going to get from the flat velocity or create a rotation from its x-axis, and from there we are going to get the right vector because we are rotating forward. So we are rotating in this direction and in this direction. So that's why we're getting the right vector. And from there, we are going to create a rotator from axis and angle. So we are going to create, creates a rotation from on this, and this is probably a misspelling or mistype or typo, whatever. Create a rotation from this axis and supplied angle in degrees. So the axis is the right vector from the x rotation from the flat velocity, and the angle is going to be the rotation amount. So get the rotation amount, and we are going to plug this into over here, compile and save that. Now let me just take all of this, right click, create a comment, rotate the ball like this, compile and save, and we can go over here and call it rotate ball so that we don't forget to do that. So we will need to call it here in the tick in order to test it out. If we don't do that, then it will not work. But going back over here, how we are getting the flat velocity is pretty clear. We're getting the velocity, as you can see, returns the velocity in centimeters, unreal unit seconds, blah, blah, blah. Basically, what is velocity? Velocity is speed over time. So the speed over time is how much the velocity is. So depending on the speed over the time, that's the velocity. And we're getting the velocity, breaking the vector of the velocity, getting the x and the y, and plugging that into flat velocity. This is pretty clear how we're getting that. We're getting from the flat velocity's vector length the current speed, and then from there, if the speed is not equal to null, because if we are not moving, the length of this flat velocity will be 0. And then we will not go inside of this branch and we will not rotate the ball. But if we are moving, then the vector length will be greater than 0. So from there, we did all of this here, as I already said, but probably, I didn't test it out, but I'm pretty sure that you can just rotate the ball by using get world delta seconds, multiplying that with the ball rotation rate and adding that to the rotation amount. You can try it out. And then from here, we are getting, again, from the flat velocity, we are getting creating a rotation from its x-axis and getting the right vector from there and creating a rotator or a rotation from that angle and that axis and plugging that into our rotation, set world rotation for the ball. Which means that we can basically go now over here and I can hit the play button and you will see now that if we move, you see how the ball is rotating. And notice how the ball is rotating only, you see when we go left, it is rotating backwards. If we go forward, it is rotating forward. So that is why we're using that get right vector, this right over here, get right vector. That's why we're using that, because we are rotating here in this direction and here in this direction. We are not rotating up or down or like this and like this. So again, if I run it, you will see now, pay attention, the ball is rotating. Moving forward, now we are going to create the jump for our ball because, well, we cannot progress in our level without it. So over here, right below the rotate ball, I am going to right click and we are going to get the jump, which is the input action. Here it is, input action jump. Now what we are going to do is when we press it, so over here I'm going to go in a branch, and what I'm going to test here in this condition is if we are falling, and we're going to get that from the character movement. So here is the character movement component over here at the top. It can detect if we are falling or not, which is the beauty. So from here we can say is falling. Let me just get it. Here it is. And I can plug it in over here. So if we are not falling, so if that is false, we are going to say jump. Simple as that. So there you go. Compile and save that. So again, the character movement component has some built-in features. It can jump, as you can see over here, target is character. It can jump on its own. It can also detect if we are falling down from the sky or basically falling down from the air. So we can use that from the character movement if we are falling. So if that is false, then we can jump. And we can test this out right away. We can go back over here. We can hit the play button. We can move. As you can see, now I can jump. Pay attention. You see? Bam, bam. We can jump. But, well, as you can see, the ball is not jumping that high. What we need to do is select the character movement and change some things over here, such as the gravity scale, for example. We're going to set that to 3.5. We are also going to set over here max step height. We're going to leave that. So walkable floor angle, we can leave that. We can set it 45 just to a random number. Maximum walk speed, I'm going to set that to 800 instead of 600. I'm also going to check this checkbox, can walk off ledges when crouching, which basically means that we can walk off ledges. Also over here, ball or jump Z velocity over here, it's at 420. I'm going to set that to 1,800. And over here, air control, we're going to set that to 1. So if you hover over when falling, amount of ladder movement control available to the character. 0, no control, 1, full control at max speed. So basically, we're giving full control to the character of the ball when he is falling. Also over here at the bottom for the maximum custom movement speed, I'm going to set that to 800. Basically, all these things are self-explanatory. So maximum movement speed, custom movement speed, basically how maximally the speed can be by which we are moving. Over here for the air control, we already explained that. Jump Z velocity, initial velocity. So basically on the Z when we jump, how high that velocity is. Can walk off ledges when crouching. We already explained that. So on and so forth, yada, yada, yada. We don't have to explain all of that because As I said, they're self-explanatory. So now we can go back over here in our game and hit the play button. And when we jump now, the ball is jumping higher, as you can see. And everything seems perfectly fine, and it is. Except when we get over here to this edge, we cannot bounce off of it. And we saw that when we jump on the edge, or on the ledge over here, that we are able to jump from another ledge to another ledge, as you saw in the preview, from here to here to here to here, so on and so forth, but we cannot do that. How can we actually do that? Well, for that, we need to create something called a line trace by channel. So we need to go back over here, and from the true, meaning if we are falling, which means we are already in the air, we have jumped. So if that is true, we are going to say line trace by channel. There you go. And I'm going to move this a little bit over here because we have some calculations to do. The line trace by channel will trace a line from the start till the end, and it will give us a hit if we hit something. So from where to where we are going to trace that line? First things first, we are going to get the actor forward vector. So over here, right click, get actor forward vector. There you go. And I think I need to move this a little bit further over here because we will have some calculations. So over here. So what we are going to do now is from the actor forward vector, we need to do some calculations. So over here, we're going to multiply him. So multiply him with a float. And what float is that going to be? Well, first, let me just set this like this over here. Now I am going to get the capsule component. So getting the capsule component, and from the capsule component, I'm going to get the scaled sphere radius, or get scaled capsule, scaled capsule radius. Why did I say sphere? Because this is a capsule. This will return the capsule radius scaled by the component scale. So basically the scale of the radius, or capsule radius, is 75. We are going to scale it by the radius, and the radius is basically 1. So that is what we are, component scale, which is basically the scale of the component, which is 1. So after that, we are going to say from here, plus float, and we are going to add to it 10. So the value of 10. And this is the value that we are going to plug in over here to multiply with the vector, with the actor forward vector. Because now, let me just move these a little bit down. Here, I can get so I can say get actor location. And what we need to do is from here, we need to subtract. So we need to say minus vector. And we are subtracting it from here, and the line trace can go over here. And this is the start of our line trace. There you go. Now, where is going to be the end of our line trace? Well, from here, again, I'm going to multiply this with a float. But again, let me just click on it over here. Something like this can do. I'm going to move this bad boy over here. Again, we need to get the capsule component. Here you go. And get scaled capsule radius again. So move it over here. And again, we're going to add to it 10. So plug this in over here. I'm basically just copy and pasting this. You can select it. You can Control C, Command C on Mac, and Control V, Command V on Mac. And after that, we are going to, and I think I can move these down just so that they are a little bit better to read. So like this. Yeah, this can work. So then we are going to plug this in over here, but this time we are, as you can see, we are multiplying everything, but this time over here, we are going to get the actor location. So copy and paste the actor location. And here we are subtracting, but now we are adding. So plus vector, and plug this in over here. There you go. And this one goes over here for the end trace. There you go. So this is the beginning and the end of our trace. And what this will do is create that trace line for so compile and save that. This will create the trace line from the ball. So if the ball is here, and since I added 10 over here, it's basically going to create a trace line like this. So this is the trace line that is going to be created from here to here. And it is going to detect anything that we touch within that trace line. So what's gonna happen after that is that we are going to go in a branch and we are going to detect if we have touched something. So here, return value, it's going to be plugged in the condition, which means basically if we did touch something, because you see here, does a collision trace along the given line and returns the first blocking hit encountered. So if we have a return value, true if there was a hit, false otherwise. That means true, we have a hit. After that, from this true, we are going to go over here and we're going to launch the character. So launch the character. Now, what this will do is, as you can see, set a pending launch velocity on the character. This velocity will be processed on the next character movement component tick, and we'll set it the following and we'll set it to the following state. So yeah. Basically what this means, it will propel the character. Simple as that. But as you can see, the explanations here can be complicated, but this will just propel the character. Now, what we are going to do is from our out over here, what we are going to do is we are going to break the hit results. This hit result, as you can see, this will be that game object or that actor, whatever that we hit with this line trace. And what we are going to do with it is over here, I'm going to right click and I'm going to say get actor location. I'm going to right click over here on the return value and click on split structure so that we can have X, Y, and Z separately. And I'm going to take the X and I'm going to subtract from it. So I'm going to say minus float. And the float that I'm going to minus it from is going to be from this location. Right click and split the pin structure. And we are going to take the X and plug it in over here. The last thing that we need to do is take this and create a sign out of it. So the sign value, as you can see, returns -1 if A is greater than 0, 0 if A is 0, and +1 if A is greater than 0. I will show you what this will do. And from here, I am going to multiply that with the float. So multiply it with the float, and basically this is the amount by which we're going to propel the character. So let's say 800, and we're going to plug it in for the launch velocity, or actually, excuse me, delete it, promote to variable, or actually split the pin structure. So this goes in the launch velocity for the X. The Z launch velocity is going to be 1,400, and we're going to override all the axes. Overriding all the axes basically means that we will use this new velocity for it. Simple as that. So just use the new velocity and there you go. So compile and save that. Now, one thing that we can also do is use this debug, draw debug type, and we can say this persistent and compile and save that just so that we can see the line trace that's being drawn. So did you see it? Here it is. This is the line trace that is being drawn. So again, there you go. You see, this is what we are doing. There you go. We are drawing these lines. And as you can see, as I said, there's something like this. So this is the line where we are drawing it. Why is this important? Because now when we go over here, we will be able to touch these and we can bounce off of them. You see? You see now how we can bounce off of these? But before that, we were not able to do that. Now, the reason why we are able to do that, because as you said, this right here now makes it is a little bit clear because you saw the line that is being drawn. So the line is being drawn from this calculation, and this is an arbitrary number that I added. So it's not like you always add 10 and it will be perfect. No, you can experiment this. You can add 15, 20, 30, 40, 50, a gazillion, but you get the point. And we need to, go back from here. This is the start and this is the end. So that's why I subtracted over here and added over here, because the end needs to be greater and the start needs to be smaller so that it can start from here and go up to here, for example. Now we can remove this. We don't need to draw it again. And this right here, we explain what it is. This is pretty clear. We got from the hit the details from the hit, the object that we hit. We got its location X. We are subtracting the location X from our own actor and the location X from the actor that we hit. Now, what is this sign? Well, basically, this sign will stabilize our character. I don't know how to explain it better except by showing you. So I am going to break the link over here, and I'm going to plug this in over here just so that you can see what's going to happen if we don't have this sign. And let's go over here, and now you're going to see what's going to happen if we don't have this sign to stabilize our character in the air. When I say character, I mean the ball, but it can be any other character. Now notice now when I jump, bam. You see? I've jumped off that cliff, or the edge of the cliff where I was, and it can happen, the same thing can happen over here. You see? Actually, I cannot jump on that, so let's try it again over here. Again, when I jump, you saw before we tested out, it worked perfectly. We were able to bounce off of this, but now, you see this. So that's why we're using this sign to practically stabilize our character in the air. So compile and save that. This will stabilize it in the air. How that math works behind the scenes, I have no idea. Don't even try to ask me. But this, as you can see, will stabilize the character. And if I go back again, you will notice. So anytime you need some stabilization, especially in the air, you can use that sign to convert that float into a more stabilized value. Because now, as you can see, pay attention. It only allows it to go to -1 and 1. As you can see, if I hover over, it returns -1 if a is greater than, actually, if a is less than 0, 0 if a is 0, and +1 if a is greater than 0. So it will stabilize, it will allow it to be between -1 and 1, and that's why our jump now is working, and we can bounce off that rock, or however you want to call it, when we come close to it, because otherwise, you saw what happened. We got propelled like a gazillion years in time. But yeah, this is for our jump. The last step that we can do is, I can actually now select all of this, and we can move it a little bit back. So something like this, and we can select it, right click, create a comment, player jump. We can call it like this, compile and save that. So yeah, it's actually player, not player jump. It's player jump. There you go. Compile and save that. And we don't have to call this with the tick event because, we just need to press the function, press the button that is connected to this function in order for us to jump. But yeah, anyways, this is how we can utilize the jump in order to, jump smoothly with our ball. Okay, the next step is to go back in our player ball blueprint, and right here below create another custom event. So this one is going to be, custom event, and this one is going to be power damage. There you go. Just come closer to this bad boy. Now, what is this going to do? Well, basically, we're going to have power when we pull together the cube that we have in our game that we saw in the preview. So when we pull it, we have power that will be drained when we do that. Now this power is going to have an input, which is a parameter, and it's going to be a float, and that one is going to be damage like this. There we go. So compile and save that. What we are going to do is from here, we're simply going to set the power. So set power, but to which value are we going to set it to? Well, the value is going to be, we are going to take over here the damage, and we are going to multiply that. So multiply the damage, and what am I typing over here? So multiply the damage with the get world. So right click, get world delta seconds. There you go. And plug this bad boy in over here. So we are going to get the world delta seconds, multiply the damage with that, and we are going to get the power, the current value of the power. And we know if we select the power over here, the default value is 100. So from here, we are going to say minus float, and we are going to subtract this value. So we're going to subtract the damage that we pass as a parameter over here, multiplied with the get world delta seconds. Now, also what we are going to do is we are going to clamp this value. So clamp the float. And the value is going to be, this is the value that we want to clamp. And the value is going to be from minimum to maximum, which is 100, like this. And that is what is going to be set to the power. Now, what is clamp? Well, clamp basically, if you hover over, returns the value clamp between A and B, inclusive. And that's enough explanation for you to get confused. But basically, clamp means it will make sure that this value over here will not go below this value, and it will not go above this value. So this is what we are doing. So it will not go below this and not above this. And next we are putting that into the power. The next step from here is to, and let me see what we have over here. So next we have the change ball material color. And over here, the material color is going to be changed by using the power, plugging in the power over here, and the parameter value is going to be power. So make sure that it's capital P. And if you're not sure, you can go back in the material itself and take or get that value, the name of it, that is. Next, we're going to go inside of a branch. So branch, there you go, which is an if-else statement. And the condition for the branch is going to be taking the power over here. We are going to test if the power is less than or equal to. If the power is less than or equal to 0, excuse me, not 100. So if the power is less than or equal to 0, that means we don't have any more power. We have died. So from here, if that is true, we are going to say set is dead. Check the checkbox to make it true. And from there, we are going to change ball material color. And the material name or parameter name is going to be is on, and the value is going to be 0, which is going to, make it look like we have died. It's just going to turn off the ball. And last but not least, we are going to enable disable input and make sure that this checkbox is not checked. So compile and save that. So let me just right click, create a comment section, and this is power damage. Now, again, I don't think that there is a lot of things that we need to explain over here because everything is basic, just subtracting and multiplying and so on and so forth, basic things. This is to smooth the value out. So multiplying the damage with the world delta seconds to smooth the value out, because if we pass here the damage to be, 5, it will subtract pretty quickly if we subtract it directly from the power, especially if it happens multiple times, in a second, for example. But when we use get world delta seconds, it will make it a little bit slower, so it will smooth things out. And here we are changing the material color. We saw that in the beginning, we explained all that, so I don't think there is a need to do it again. But if something is not clear, make sure to ask in the comment below. And last but not least, we have another custom event, and we will test these two out shortly. We will come back to these two, don't worry about that, because we cannot test them right now. And this one, custom event, energy damage, this is the name of it. As I said, we cannot test these two functions right now, or events, power damage and energy damage, because we will need to have the ball. Actually, we will need to have the cube, and we will have the lasers. But before that, we are going to have the UI to display that to the user. Everything will come shortly, don't worry about that, and I will revisit this again to explain it. So over here, again, we're going to have an input, which is the damage parameter. And what's going to happen is, from here, we are going to set the energy. Here is our energy node. And the value we are going to set it to, we are going to multiply with a float. And click here to add another pin, because we're going to have 3 inputs over here. The first one is going to be get world delta seconds. As you can see over here, plug this in over here. And for the third one, we're simply going to say 1. And then we can move this over here, get the energy, and the default value of the energy, by the way, is 100, as you can see over here. And now that we have the energy, we are going to subtract from it, so minus float. And now that we have that, we are going to plug this in over here and clamp the value, which is last thing that we need to do, clamp the float. And we are going to clamp this value between 0 and 100. Same thing as what we did with the power above. So going back over here, plugging it in over here, and there you go. Compile and save that. Now, what's specific here for this energy? I'm just going to create a comment over here, and energy damage. Over here, I'm going to say positive values are equal damage and negative values are equal to heal. So when we pass a positive number in the damage over here, then what we are going to do is we're going to deal damage. When we pass the negative value, we are going to heal that. And your assignment is to comment below how does that actually work. So make sure that you, for example, pass here 10 and then minus 10 and see how that works. You can use print and so on and so forth. But I want you to figure and dig deeper into that and see how that works. Now, we do need to take this energy damage. And what did I do? And we need to go over here inside of our tick event, and from here we need to call energy damage. And what's going to happen over here, the damage value is going to be negative 25, because as I said, the negative value over here, as you can see, positive values equal damage, negative values equals heal. Compile and save that. But as I said, make sure that you dig in, experiment, use the print function or print, however you want to call it, to print out the values over here of the energy. You can do that by creating another node and so on and so forth, but I don't want to give you any more tips because I want you to investigate that and for you to actually see it. Now, unfortunately, as I said, we are not able to test this out right away. We still need to create the lasers, we need to create the cube, and we need to create the UI. And when we do that, we will come back to revisit these lines of nodes or code to explain them again what is happening. So let us now create our game HUD. So we're going to right click over here in the blueprints, and we are going to go under user interface, and we're going to create a widget blueprint. And we're going to call this bad boy BP underscore, not plus, game HUD. There you go. And double click this to open it over here, and voila, this is what we need. Now, of course, we're still not finished. What we want is a progress bar. So we want one progress bar, we want another progress bar, and we want a text. There you go. And is it a rich text block or a simple text? Actually, a simple text, not a rich text block. So we can delete this and we just want the text. Okay, so the progress bar, first one over here, is going to be the power bar. The second one over here is going to be the energy bar. And the text over here is going to be our interact text. So I'm going to just leave it like this for now. But what we are going to do? Well, first things first. The anchor for this power bar, which is basically a slider, is going to stay at the top left corner. Now the position X is going to be 24, the position Y 24, the width and the height, so size X 256, size Y 24. There you go. So this is how it looks like. Pay attention. Look, a very nice slider. Yada, yada, yada. Now what we are also going to do is, for the style, click on the drop-down list, and we have the, under style, we have the background image, and we have this tint color. Now, the tint color for this one is going to be red. So let me just click on it over here, and linear hex color. Yeah, here it is, red. So there you go. This is going to be the tint color for the power bar. Is it the power bar? Yeah, power bar, excuse me. So I forgot. And for this one, so going down over here, the appearance, fill, color, and opacity, click on that one. And over here, we're going to have the green one. Now, just 1 second. I did this quickly. So this is over here, the hex linear color that you need to type 0DFF00FF. This is for the green one. You can pause it to type it out. And for the red one is over here. Let me just go and show you. It's FF0000FF. But, you know, you don't have to do it exactly like I'm doing. But if you want to follow along everything, there you go. Also over here for the percent, as you can see, we can move it left and right. So 0 over here is, well, 0. And when we are moving it to the 1, so this is how we are going to leave it. So that is how it is going to look like. This is for the power bar. Now going back to the energy bar. So let's select the energy bar. We're also going to leave the anchor at the top left corner. And over here, we're going to set the position X to 24. The position Y is going to be 56. The size X 128 and the size Y 24. There you go. Now for this bad boy, we're also going to change the color. So let's go over here under style, click on this one. And for the hex linear, paste in over here 000 A0C FF, or simply pause the video and copy and paste it and click on OK. Now for the color, which is the regular color over here, we're going to leave it as is. So now if you go over here, you see now this is what we have. So when you move the %, there you go. Compile and save this bad boy. Last but not least, for the text block, what we are going to do is we're going to set the anchor at the top center. So this is where the anchor is going to be, as you can see over here. The position X for our bad boy over here is going to be -128, so -128. 40 for the position Y. The size for the X is going to be 256 to 256, and the size X, 256, the size Y is 40. There you go. We're going to align the text in the middle, and simply over here, we're going to say E, like in quotes, in single quote, E, single quote, to interact. There you go. So this is what we have. Compile and save that. Now, again, this is not something that, you need to follow strictly what I did. You can experiment with these. You can even create a better slider than these that I have created. So be my guest and experiment. This is what I want you to do. That's how you learn the best. Now, what we need to do in order for this, and let me just close this ball material. Yes, close it. Yeah, I don't care. What we need to do in order to spawn this bad boy inside of our game is go over here in our game mode. And previously in the beginning of the level, if you remember when we deleted here from our level blueprint and we said over here open level blueprint, we deleted from here 2 nodes. Well, these 2 nodes were actually spawning the UI inside of the game. So these 2 nodes were spawning the UI in the game, and we can do it either here. We can also do it over here in the game mode. It's not important. So in the game mode, in the event graph, over here we can delete the tick event, and in the begin play, we can do something like create widget like this. So create the widget, and the widget that we want to create is BP game HUD. And after that, add to viewport. And who are we adding to viewport? Well, the returning value, which we are going to put over here. And there you go. So simply compile and save this bad boy. So again, over here, just create UI widget. And from the class, we can select the one that we have created over here, which is our BP game HUD. There you go. And from there, we simply need to add it to viewport to make it visible. And who are we adding to the viewport? The returning value that's been created from this class over here. So if we were to go now in our example and hit the play button, there you go. We have our UI. At the top left corner, we have the power bar, we have the energy bar, and in the middle, we see that we have E to interact. Now, of course, this E to interact will not be visible right away from the beginning. Instead, when we come close to the interactable game objects or actors. But in order to do that, we, of course, need to do a couple of other things. So the first thing that we need to do is go back over here inside of our game HUD, and we can close the game mode. And next, you have the designer and the graph over here. If you take a look at the top right corner, so we are currently in the designer where we can, design this, but when we go in the graph, this is where the nodes are being constructed. So what we need to do is we can delete this pre-construct, and in the construct, the first thing that we are going to do is get a player reference. Over here, I'm going to click the plus button, and what I'm going to do is I'm going to say player ref. There you go. And this is going to be our player character. So, or ball. How did I name the player? BP player ball. So object reference from him. Also over here, let me go back in the designer and select the text over here, E to interact. And when you select it, over here at the top, you have this is variable. So click on that and compile and save that. The reason is because we also want to make that text block a variable. And you can rename it to interact text or something like that. Can I click it over here? Actually, we need to rename it over here. Text block 25, interact text. There you go. So compile and save that. And when you go back over here, there you go. We have the interact text. Now what we need to do is we need to take the player reference and set it. So how can we set it? Well, first things first, we need to get the player pawn. Player pawn. And from the player pawn, we are going to go over here, cast to BP player ball. And who are we casting? We're casting the player pawn. If that is successful, if it works, then we are going to set the returning value as a reference to the player character that we have just over here created. After that, inside of our player character blueprint, we need to go over here, and at the bottom, you see over here we have the HUD reference. Well, now we need to change this type variable from Boolean to game HUD, BP game HUD, and go over here, object reference, compile and save that, and there you go. So now also make sure that it is a public variable so that we can now access it over here, because now what we are going to do is from our player reference, so take the player reference, and from here we are going to say set HUD. So set HUD reference, and this is going to go over here. So the execution order goes over here. And who are we going to set? Well, we're going to set this game HUD blueprint, and for that we're going to type self, and over here get a reference to self and plug it in over here. Now, what the hell is this self? Self basically means it refers to itself. So it is referring to this game HUD blueprint. Now over here we need to do one more thing, which is call another function that we still didn't create. So let's go quickly create them over here, right below the tick event. And in the tick event we will do another thing. So over here we have custom event, and we're going to have two custom events. I'm going to copy and paste this one. So I'm going to select this custom event, and come on, can you just, why isn't this working? For some reason, I cannot rename it. I don't know why. There you go. So show interaction text. There you go. Another custom event. Right click, custom event, hide interaction text. There you go. Now what we're going to do is simply get the text or interact text. There you go. From here, we're simply going to say set visibility and plug this in over here. So plug it in over here. The visibility, if it's show, we're going to make it visible. Copy and paste it. If it's not, we are going to set it to hidden. There you go. So compile and save that. And what we need to do at the top over here, after we set a reference to the UI HUD in the player blueprint, from here we're going to hide the interaction text, which means now, let me just compile and save that. And if we go back over here in our example map, hit the play button, you see we don't have the interaction text. Previously it was here. If you remember a moment ago, it was there. But now we don't have it because, well, now we are hiding it. So we are doing that with these two events. Now what's going to happen here inside of our tick? In the tick, we're going to take the player and we're going to test if he is valid. So is valid, but we want this one with a question mark, not the one with the F mark, but the one with the question mark. And this goes over here. So if the player character is valid, which means we have a player, he is not dead, we are going to take the power bar from here, get the power bar, and we're going to say set %, and this goes over here, and the % that we're going to set for the power bar is going to be from our player. So we're going to get the player, and from the player we're going to get the power. And after that, so we have the player, we have the power, then we are going to divide that by float, and that division is going to be by 100. And then plug it in over here. Why by 100? So compile and save that. If we go back over here, if you take the power bar, pay attention now. So over here, here is the %. As you can see, the value goes from 0 up to 1. So if the power value is 100, we need to divide that by 100 in order to get the number between 0 and 1. Because if it's 90, if the power drops to 90, if we divide that by 100, that means 0.9. So on and so forth, you get the point. And we're going to do the exact same thing for the energy bar. So going over here, first we're going to take the energy bar, get it set percent, exactly the same thing we're doing, but this time for the energy bar. So plug this in over here, this goes over here, and now getting the player reference, getting the energy, so get energy. There you go. And the energy also needs to be divided by a float, and that division is going to happen with 100. Again, for the same reason, plug this in over here and make sure that you compile and save that. Now, this is in the tick event for the UI HUD, which means we don't have to do anything else. The tick is being updated on its own, and basically it will also update this when the player's energy and power updates. Of course, if we go back over here and we test this out, nothing will happen because we don't have the lasers who are subtracting energy from us. We don't have the cube that we need to move that are going to subtract our power, so on and so forth. So the next step is to start creating them. Moving forward, the next thing that we want to create is our laser. So over here in the blueprints, we're going to right click and create a blueprint class, and it is going to inherit from the actor, and this is going to be BP_laser. And inside of the laser, first we are going to set the laser. So select the default scene root, and from here add a component which is going to be a particle system component. There you go. So this is going to be our particle system. Let me just go back over here where our objects are. And why, for some reason, is this not slowing down? And when I say this, I mean the movement of the mouse and stuff like that. So yeah, anyways, for the particle system over here where it says particles, so over here, for the template, click on the drop-down list, and we want the electricity arc. This one. This is the one that we want. Now, this one, or actually the P electricity arc. Let me just find it over here. Arc, like this. Here it is. The P_electricity arc, not directly electricity arc. So this is the one that we want. So compile and save that. And basically, yeah, we don't have to change anything else. We can leave it as is. And there you go. Now, if we go back here inside of our example map, and what I'm going to do is, let me just go over here in the world outliner. I want to create a new folder, and that folder is going to be lasers, who is going to hold our lasers. And I'm going to put this first laser over here, and I'm going to put it under this one, so under the folder. And the position for the laser is going to be 730. For the X, for the Y is 0, and for the Z, 821. There you go. Voila, so this is where our laser is going to be. Now, if we were to run the game, of course, nothing's going to happen. We are just going to come here close. We're going to see the laser like this. But the laser needs to fire like this over here, not like this. So in order to fix that, we do need to go back over here in our laser actor and come inside of the event graph. And we don't need the begin overlap, we don't need begin play, we need the tick event from here. And for the laser, what we need to do here, we need to create two variables. First one is going to be trace max length, and we also need laser direction. So laser direction is going to be a vector, which is going to determine the direction of the laser, and the trace max length is going to be a float. So compile and save that, because now for the trace maximum length, we need to set the value for it. So the default value is going to be 100,000. So 100,000 is going to be for the maximum length. And what we need to do over here in the tick event, we are going to create a line trace by channel, same as what we did with our ball that was enabling us to jump. But this time we are doing this with the laser so that we can detect the player and actually deal damage to the player. So over here I am going to get the actor location, and this is the location of the current actor, which is our laser. What do I need with the location? Well, over here we need to get the laser direction, and we also need to get this trace max length, And we need to add, or actually first multiply these two. So first over here, the laser direction multiplied by float, and the float is going to be trace max length that is going to be multiplied with. And then we are going to add two vectors. So the actor location, vector plus vector, this is what we want, adding to the product of these two. So now when they are added, this is going to be our end trace channel, and the start trace channel is going to be the actor's position directly, or the actor's location. So as you can see, and we already know how the line trace by channel works, we saw that with the ball, but again, as I am, just briefly explaining it. So the start is from the actor's location, and the end is from the laser direction multiplied with the trace maximum length plus to the actor's location, which means it's going to be way over here. And it's going to, shoot that line. And what's going to happen from here is that we are going to go in a branch. And we know that a branch is an if-else statement. The condition is going to be the return value, meaning if we hit something, it is going to, be returned. Now, also what we are going to do is, if the hit value is true, we are going to set from the particle system over here, we are going to set the beam source. Set beam source point. Here it is. And the beam source point is basically from where the beam is going to start. So if it's true, we are going to put it over here. Now, the new source point is actually going to be the actor location. So we can copy and paste this bad boy over here, and I can move this over here, and I can plug this in over here. So the new source point is going to be the actor location, or the location of the current or the whole actor holding this particle emitter. Now also what we want to do is from here, from our out hit, we want to break this. So break the hit point, and this can be a little bit over here and over here just for readability purposes, so to say. Next, what we also need to set is, we have the beam source point, we also need to set the beam target point. So from here, we are going to say, but first we need to get the particle system. So copy and paste the particle system. And from here, we are going to say set beam. So set beam target point. So the source is where the beam is starting, but the target is where the beam is going to hit. So like his last destination. The last destination is going to be the location of the hit that we, got from the line trace channel. So that is going to be the new target point. Next, what we want to do is from here, from the other actor or the hit actor from here, we want to cast to the BP player ball, try to cast it. So we are going to say cast to BP player ball like this. So we are trying to do that, and we need to get from here the hit actor and plug him in over here. And let me just double click this bad boy so that we can do it like this. As you can see, we are taking the hit actor. The hit actor is basically what we hit or touched with the line trace channel. If that is castable, or if we can cast him into a BP player ball, that means we hit the ball. And if we hit the ball, what we need to do is we need to get from the ball the power damage. So from here, we're going to say power damage, as you can see, which is our function, and the damage is going to be 50. And I can compile and save that. There we go. And if I go over here in our player ball, and this is our energy damage, this is the power damage. So we're going to take the damage, multiply it with the get world delta seconds, then subtract from the power, then set the value over here, and then use the change ball material color, yada, yada, yada. You get the point. But what's even prettier is that we can go here in our game HUD, and over here in the tick event, we are using the power to set the percent, and we can see all that visually being represented now. So before we go back again and briefly explain what is going on over here, even though I don't think there is a need, but I will go briefly, like in a minute or in a second, explaining everything what is happening. But if I go back over here and hit the play button, notice now the power. So pay attention at the top left corner, and let me just take a look at, oh yeah, silly, stupid teacher me. You see what I forgot over here? I mean, you don't, but over here, the laser direction, compile and save that. The laser direction for the X needs to be -1, or otherwise this will not work, because we're using over here the laser direction. So as you can see, multiplying with the trace max length. If the laser direction is 0, 0, 0 on 3 axes, if we multiply that with any number, it's going to be 0. So it's not going to work. Also, another thing that we need to do is go in the player ball and select his capsule component. And over here for the collision, we need to change this collision from the pawn to custom. And over here, we need to have the collision enabled to query in physics. And we can also block all over here. It's not important. But what's important is that we have this query and physics. So collision enabled, basically. And if we don't have this, then we will not collide. And I can just demonstrate that quickly. So if we have a pawn over here, like it was a moment ago, if I hit the play button and go now to test this out, it will basically not work. There you go. Nothing is working, and voila. But if we go back and select the capsule component, set this to custom and put it to collision enabled, and we can block everything. It's not important. Compile and save that. So if we go back now and hit the play button, so now when I come over here, pay attention at the top left corner. Notice now how the laser is, well, destroying me. And also you will notice how the laser, when he touches me, when he touches the ball, and pay attention, I cannot move. Now I'm dead. When he touches the ball, he's like cut out. He goes only to the ball. So the laser goes from here. And for example, if he touches the ball over here, he goes only to here. He doesn't go above the ball, as you can, well, see. And if I go back over here, and the reason why it cuts out on the ball is because of this beam target point is set to the break hit result, or the hit result that we have from here, and its location. So there you go. And if we have the player, we are getting his power damage. And what we are doing, we are calling it by using damage 50. And we saw what's happening. So we saw the top left corner, and this over here, we saw it, how it's being calculated, so on and so forth, yada, yada, yada. I've already explained that. So basically, yeah, if something is not clear by any chance, I believe we explained everything over here, and in the ball we already explained what is happening. If something is not clear, just make sure to ask, and I will, help you out. But before we, proceed on other parts, we are also going to copy and paste this laser, because we are going to have another one. So this laser is going to be at the position X for 7, 6, 7, 9. For the position Y, 0, and for the position Z is 2, 6, 1, 1. There you go. So this one is going to be over here, as you can see. Now we are going to copy and paste this one as well, because we are going to have the third one, and the position X for the third one is going to be 7, 6, 8, 0, and 0, 0 for the, or 0 for the Y, and for the Z, it's going to be 2, 4, 4, 8. There you go. So compile, or actually save the current. And if I hit the play button, let me just eject myself. And if I go over here, there you go. So pay attention now. We have these two lasers over here. And of course, we will need our cubes in order to, overcome them, which, well, will be the next thing that we are going to create. So inside of the blueprint folder, we're going to right click and create a blueprint class, which is going to inherit from the actor. And this is going to be interactive. Hopefully I can spell. There you go. Interactive block. Double click the bad boy. What we need to do. First things first, select the interactive block here over here at the top, click on add component and filter for the physics constraint. There you go. And drag the physics constraint to be the root object. Now, what the hell is a physics constraint? If you hover over, this is effectively a joint that allows you to connect two rigid bodies together. Basically, it will allow us to pull the cube easier with the ball. Simple as that. So what we are going to do first here, the component name for our physics constraint, we're going to say here collision for 1. Now also what I'm going to do is over here for the linear limits, I am going to set everything to be free. So linear limits means we can linearly indicates the linear constraint applied along the x-axis. Basically, if we can move our constraint on the linear x-axis, linear y, so on and so forth. Over here for the swing 1 motion, we are going to have it locked. And over here, it's free for the swing 2 motion. Twist motion will also be free. And I think that's all there is to it. That's all there is to it that we need to do. So compile and save that. Next, select the physics constraint and filter for our static mesh component. So filter over here, static mesh, there it is. And I'm simply going to call it mesh, which is going to contain our cube. So you can click here where it says over here to add that mesh and filter for the cube rounded. So this is the one that we want, the cube rounded. There you go. Now, what I'm also going to do is over here for the cube, we need to check this simulate physics checkbox. And for the mass in kg, over here from 100, we're going to set it to 3000. Linear damping, we're going to set that to 2. And now you can hover over and see what it is. Drag force added to reduce linear movement. So a lot of these things, well, basically all of these things are self-explanatory. So you can, just hover over and see what they are. Over here for the collision, we are going to check this simulation generates hit events. And over here for the collision presets, we are going to leave that to physics actor. But over here for the physics material, we are going to select the slide physics material. And what the hell is this? Well, if you double click on it and if you go inside, this is basically a physics material that will allow the cube to slide when we start dragging it smoother. You see the friction is 0, meaning it will not have any friction when we move it. As you can see over here, override friction combine, restitution, so on and so forth. But basically, when you play with these settings, depending on the friction mostly, because the friction is when the actor is being dragged over another actor, so how they touch each other, will there be friction or not? When it's 0, well, it's not it's 0, there is no friction, which means this one will slide. Think of it like if you have a game, for example, where you want to create ice or an ice terrain, well, you will use 0 for friction because ice is slippery. There you go. So now we have our mesh. Next, what we need to do is select the mesh. And for the mesh, I am also going to add, so before we do anything, I'm over here on the z-axis. I'm going to set it to -278. There you go. And also what I'm going to do is on the box extent, or actually this is for the trigger detection, excuse me. This will be for the trigger that we are going to add to the mesh, so excuse me for that. So first select the mesh and filter for the box collision. So there you go. This is where I made a mistake. So the box collision, or we are going to rename it to detection trigger. There you go. So this is my mistake. And now what we are going to do with this bad boy is now we are going to, on the z-axis, to say -278 to set the value a little bit down, as you can see. What I'm also going to do is here for the box extent, X is going to be 1000. So 1000, Y is going to be 130, and Z is going to be 300. There you go, which is going to, well, look like this. So it looks like this. And compile and save this bad boy. Now, last but not least, we're also going to select the mesh and attach a particle. So here it is, particle system. And I'm going to click on this bad boy, and this is going to be our beam. There you go. And it's not important to capitalize the B, but yeah, I'm going to capitalize it. So over here for the template, now we are going to select the electricity arc. So electricity arc, not the one like we did if I type arc over here, not P underscore electricity arc, just electricity arc. So select that one. And what I'm going to do for the beam is I am going to rotate him 90 degrees on the z-axis. And basically that is that. So we can compile and save that. Now, if I were to go and put this block, so if I go back over here, let me just right click and create a new folder, and this one is going to be interactive elements. So interactive elements folder, where we are going to put our interactive elements. If I go into the blueprints and put the interactive block, and I'm going to put it over here, interactive elements. And if I position the first one, is going to be at 2806, 0 for the Y, and for the Z, 1125. There you go. We are also going to rescale it. So over here, click on the lock icon for the scale. And over here, the scale is going to be 1.5. There you go. So compile that or save the current. If I hit the play button, we can come close to it. And we can jump on it and all of that stuff. So that is totally fine. But, you know, nothing is happening because we need to be able to drag it towards us in order to move it over here so that we can then jump from here to here to here to here to here. So you get the point. So let's go back in the BP interactive block, and here in the event graph, the first thing we're going to create a couple of variables. So click here. We're going to have one variable, 2, 3, and 4 variables. The first one is going to be the player reference. So player ref, so reference to the player, which is going to be a type of our BP player ball. So ball, and there you go, object reference. The second one is going to be the move direction. So move direction, and this is, as you can assume, a vector. So we are going to have a vector. Next, we're actually going to have one extra variable. So the next one is going to be can be pushed, and the third one is fourth one, that is going to be can detect player. And last but not least, we're going to have the UI HUD reference, so UI HUD. Now these two are going to be booleans, as you can assume, but the UI HUD is going to be the game HUD. So HUD, BP game HUD, object reference, compile and save that. Now above our, first I'm going to delete all of this. And above the begin play, we are going to create a custom event. So over here, we're going to say custom event, and we're going to call this one lock all rotations. And this will not allow the rotations, or it will not allow the game object, the actor, to rotate. So what's going to happen from here is we're going to get the physics constraints. And from there, we're going to drag a node, and we're going to say set angular swing 1 limit, and we are going to continue the execution flow from there. And motion type is not going to be free, but it's going to be locked because we are not going to be allowed to move. From here, we are going to have our physics constraint, and we're going to say set angular limit or swing limit 2, and this goes over here, but I am going to do something like this and like this so that it is more readable. So over here for the angular swing 2 limit, it's also going to be locked. And last but not least, we are also going to move from here. We're going to say set angular twist limit. Here it is. Plug it in over here, but I'm also going to double click on this to create another line or dot on this node line. So locked, there you go. So this is going to be our lock all rotations, which is basically not going to allow our node or actually our actor to rotate. And I'm going to call this one lock all. So lock all rotations, there you go. Compile and save that. Inside of our begin play, we are going to first delay. So we are going to say delay over here for 1 second. So we are going to delay for 1 second. And the reason why we need to delay is because next we are going to get the player pawn. So we are going to right click over here and get the player pawn. And from here, I'm going to cast to BP player ball or ball player, however we called it. So plug this in over here. And next from it, we are going to set the player ref. So here it is, our player reference. So plug this in. And next we are going to set the UI HUD over here. Now the HUD is going to be set from the player HUD. So come on over here. Actually, we're going to get the HUD reference, and then we are going to set it over here. Now, this is exactly the reason why we're delaying. You can test it out on your own. I'm not going to do that over here because I already tested it. So you can do that on your own, but I'm going to explain why we are delaying over here. Because inside of our, let me just take a look at over here. Was it in the player? I think it's not in the player, but it's actually in the BP over here inside of the HUD itself. So when we go in the event construct over here, we are getting the player and setting ourselves to the reference inside of the player variable HUD reference. And this HUD, if you remember, is being created in the game mode in the begin play. And over here in the interactive block in the begin play, we're getting the reference to the player to get the reference to the HUD. So by delaying here 1 second, we are allowing all of this to be already performed. So we wait 1 second before we do all of this over here, which means the UI HUD will be created. Then the UI HUD will get a reference to the player, and it will add self to the reference of the HUD reference inside of the player so that we can actually get it from here. But you can test it out. Try to use it without this delay, and we'll see that you will not have a reference to it because it will not get a chance to be created before we try to get access to it over here. So next from here, we are going to lock all rotations. And now that we have locked all rotations, next we are going to get the beam, which is our particle system. We are going to simply deactivate it because we don't want it to work before we actually start interacting with it. Now we can select all of this over here, the begin play, and I can create a comment. I can say something like initialize the cube. So like this, compile and save that. So moving forward, next, select the detection trigger. So make sure that you select it. This is really important. So first select the detection trigger, and from there right click, and then here in the search type on component begin overlap. There you go. And we want this one, on component begin overlap in parentheses detection trigger. So what's going to happen over here inside of the on component begin overlap is that we are going to try and cast. So cast to BP player ball, and we are going to cast the other actor, meaning basically the actor that we have interacted with. If that is true, so we have collided with the actor, our ball actor that is, then we are going to go from here and first right click and get the player controller. And from the player controller, we are going to enable the input. And over here, I'm going to plug this in, and not in the target over here, but the player controller. There you go. The target itself, but the player controller is the one who is going to, you see, pushes this actor on the stack and input being handled by the player controller. Next, we are going to get our UI HUD, and from there, we are going to show interaction text. So from here, like this, we're going to plug it in, show the interaction text, compile and save that. Now I can copy all of this, and we can select the detection trigger again, because now we need to do the same thing but the opposite. So right click over here, and we're going to say on component end overlap, and it's going to be the same thing as I said. So we are going to try and cast to the BP player ball the other actor if it's true, but here we're not going to enable the input. Instead, we're going to disable input. Here it is, disable the input and plug in the player controller over here because, well, now we don't want to interact. And also over here from the UI HUD, we don't want to show, but hide the text. So hide the interaction text, and we're going to plug this in over here. There you go. So I can move this something like this over here, And by the way, I am going to select these and I am going to comment them and group them in a comment. And I'm going to say here, triggers or, overlap, however you want to call it, triggers for detecting collision with player. Compile and save that. Now we can test this out. If I go back here in the example map, hit the play button, when I come close to our cube, we know that it has a large collider. So if I come close, you see E to interact. If I move away, it goes away. So this is what we just did a moment ago. Again, if we come close, E to interact, because if you go over here, you see this is that trigger. This is the box. When we come close to it or inside of it, we will see this because this is what we did over here. This is that line of code. Now, of course, this will not allow it. This is not enough for it to actually allow us to move the cube towards the ball. So we need to program that as well. So let's go back inside of our platformer, or actually interactive block, and right here below our onComponentBegin overlap, we are going to get our tick event back. So what's going to happen from the tick event? Well, this is where the magic is going to happen. This is where we're going to pull our cube towards the ball. So first we are going to go from eventing to a gate. Now, what is a gate? Well, a gate basically, as you can see, allows for opening and closing a gate to control the execution flow. So basically, when we open this gate, we enter this gate, but we need to open it to be able to execute what's after the gate. So we need to open it, and when we close it, so nothing is going to happen. So basically, this is how we control the execution flow. And in order to open the gate, we need to get our action, so which is our input. So input action, here it is. There you go. Input action, which is basically this one over here, or input action interact. You can also call it interact like this. And let me just go back and see, will this change? Will this change? So right click over here, we can say interact, and there you go. So input action interact. This is much better than input action. So when we press the button, and we know that that button is E. So when we press the button, we are going to take the beam, and we are first going to activate it. So make sure that the beam is activated. So over here, plug in the execution. And from there, after we activated the beam, then we are going to go and open the gate. Now, also when we release the button, we are going to deactivate the beam. So when we release the button, we are going to deactivate the beam, and we are going to go inside of the close gate, which means when we open it, so when we press the button, we open it, and then it will work. When we release the button, we close it, and nothing will happen after this exit. So also one thing that we're going to do is over here, create a custom event, and this custom event is going to be close interaction gate. And it's simply going to go over here to deactivate the beam. So deactivate the beam, and then from there, go and close the gate. So in these two cases, when we release the interact button, which is the E button, we will close the beam or deactivate it and close the gate. And also when we call this custom event close interaction gate, we will deactivate the beam and close the gate. Only when we press the button, we will open the gate. So what's going to happen when we open the gate? Well, first we are going to test if our player is valid. So get the player reference, and from here, we are going to test is valid with a question mark. And why we're testing that, meaning do we have the player inside of our game? So if we don't have the player, if it's not valid, we don't have it, we're going to say close interaction gate because we don't have the player. So what is the point of doing anything? Because, if we don't have the player, we cannot interact. So close the interaction gate and also take the UI HUD. So from here, take the UI HUD, and from here, hide the interaction text. So this also goes over here, plug it in, compile and save that. This is if the player is not valid, meaning we destroyed him. If he is valid, we are going to go in a sequence. So sequence, and a sequence is basically an execution order. If I hover over, you see executes a series of pins in order. First, this one will be executed, then this one, and if you have more, you see, if you have more, you can, execute them in order. But they're executed in the order 0 is going to be first one, then 1, then 2, then 3, then yada, yada, yada. So first, what we are going to do is go over here and we are going to get the player reference. So first we need to get the player reference. And from here, we are going to call the energy damage. And this goes over here like this. So I'm going to move it a little bit up. Something like this. There you go. Move it a little bit over here. Now, the damage to the energy is going to be 50. If you remember, in our player, if I double click it, you will see the energy damage. The positive values are equal damage. Negative values are equal to heal. Because over here, if we have a positive number, it is going to be, let's say, 50 multiplied with the world delta seconds multiplied with 1. And then we're going to subtract that from the energy. You see, we're subtracting that from the energy. So we're saying the positive value minus the energy, and then we're clamping that value between 0 and 100. But if we have a negative value, and I told you this is your assignment to figure out how it works. So let's go back over here. So here we are dealing damage or actually subtracting from the energy of the player. Next, we are getting the beam. So over here. And for the beam, we are going to say set beam source point. And the source point is going to be, in this case, the player reference. We are going to get the actor location, which is the location of our player. So the source point for the beam is going to be the player's location. But now the end point or the target point, so over here for the beam, I'm going to say set beam target point, basically where the beam starts and where the beam ends. So over here, the end is going to be from the mesh itself, and we are going to get the world location like this, and we're going to plug it in over here. So something like this. There you go. Compile and save that. So this is what's gonna happen first. And I think we need to do this. So like this and like this to move all of this a little bit down for obvious reasons to make it more readable. So in this execution, this sequence, first we are going to do all of this. And this is self-explanatory. I don't think that we need to go into more detail what this is. Then what we are going to do is we are going to go into compare float. And over here, you will see if I hover over, compare one float to another and indicate if it's greater, less than, or the same. Now, I'm going to double click over here so that I can create it like this. So who are we going to compare? Well, we're going to get the player reference. And from the player reference, I'm going to get the energy. And the energy is going to be the input or the one that is going to be compared. And we're going to compare it with 0.5. So depending on if it's greater, less than, or equal to, we are going to do certain things. First things first, if it's equal to or less than 0.5, we are going to close the interact or interaction gate. So we're going to close the gate, and we are going to take the UI HUD. And from here, we're going to hide the interaction text. Because if the energy gets to the value which is equal to 0.5 or lower than, and I'm going to click this here as well. And I'm going to move this over here and plug this in over here. So basically these two go, so these two execution pins go inside of this one, which go over here. Because again, if the value of the energy comes to the value of 0.5 or less than 0.5, then we are not going to continue to drag or pull that cube towards us because we don't have any more energy to do that. However, if it's greater than 0.5, then what we are going to do is we are going to get the mesh. And for the mesh, we are going to add force. And this goes over here. But don't worry, we still need to do a few calculations. It's not simply like this, because we need to add a force that will pull it together. And that force is going to be, we're going to get the player reference, and we're also going to get the mesh. And from the player reference, we are going to get the actor location. So get the location from our character, and we can move this a little bit down, just like that, and this one over here. For the mesh, we're going to get the world location. There you go. And we are going to subtract them from one another. So we're going to say minus vector. So vector minus vector. Here you go. And we need to move this a little bit further here so that we can have more space. Maybe move these a little bit backwards. Now, for this pin, I'm going to right-click and split the pin structure because I want to get X, Y, and Z separately, because now I want to make a vector. So make vector. And I want to plug X and I want to plug Y. So plug them in. And next from here, we are going to normalize this. So normalize. And after that, we're also going to get the mesh over here. From the mesh, we are going to get the mass. And from the mass, we are going to multiply it with a float. And the float value is going to be 1000. And last but not least, we still need to move this a little bit over here, because now we need to multiply this with a float, plug this in over here, and plug this in over here. Compile and save that. So now we can create a comment section from it. Tick to pull the cube to the ball. There you go. And compile and save that. And for some reason, I like to write these capitals, lowercase, big case. Anyways, it's not important. Let's go and revise this before we test it out again so that I can make sure that everything is clear. So when we call the tick event, we're going to enter the gate. The gate will open only when we press the interact button, and with it, we will activate the beam, which is the particle effect. If we release the button, we will deactivate the beam and we will close the gate. And also when we call the close interaction gate custom event, we will deactivate the beam and close the gate. When the gate is closed, this exit and everything what's after it will not execute. So everything will not execute if the gate is closed, because the gate allows us to control the workflow. If the gate is open, then everything over here will execute. Moving forward, when we execute what's after the gate, we're first testing if the player is valid, or do we have the player in the game. If we don't, close the interaction gate and hide the interaction text. If we do have the player, he is valid, first subtract the energy from the player because he's using the energy to pull the ball or the cube, and use the beam to set the source point and the target point so that actually it will look like this. This is our cube, this is our ball, so the beam will be between them. So it will be on the cube and it will be on the ball. After that, we are going to compare the float for the energy. If it's greater than 0.5, we are going to, first, if it's equal to or less than 0.5, close the interaction gate, hide the interaction text because we don't have enough energy to pull the cube. If it's greater than 0.5, then we are going to use the player reference and his location and the mesh location. We are going to subtract from the player location the location of the mesh. We are going to create a vector using the X and the Y from that calculation. We're going to normalize that vector, and we're going to get the mass and multiply it by 1000. Now, of course, these are arbitrary values like this 1000 and so on and so forth. You can test it out. You can like use 3000. You can use a gazillion. But, I've tested it out with 1000 and it works well. So using that, multiplying the mass with the mesh, and then multiplying these two together, adding that force will make it move slower. Why am I using these adjectives? But anyways, this is the calculation for adding the force. So now if I go back over here, if I hit the play button, if I come close to the cube, we will see the interact. If I go away, we don't see it. If I press E now, nothing is happening. If I come close where it says interact, and if I press E, bam, you see, it is coming closer. You see, bam, it is coming closer. There you go. Now, one thing that we do have that is not working is the following. So over here, I believe I've missed something. Over here, yeah, new auto. So target is actor component. This is not auto activate. It's actually activate, not auto activate. So this goes over here, and this goes over here, and this reset goes there. Compile and save that. So it's not auto activate, excuse me for this one. So not auto activate, it's activate for the beam, and also make sure this reset, you see whether the activation should happen, even if should activate returns false. So basically just reset the beam where it was. So activate will turn on the beam. So let's try it out now. And for some reason I, selected the auto activate. I didn't even notice that. So now if I move it, you see, there you go. So if I come close now over here and I'm moving this cube, now I can do this. So here, there you go. And I can go over here, but now we cannot pass these without the other cube. Actually, we can, but we will die. Yeah, so we need other cubes inside. So let me just quickly add those other cubes. So we are going to have interactive block 2. So let me just, this interactive block 1, copy and paste it. The interactive block 2 is going to be at 7,909 for the X. Y is 0. Z is 3,081. There you go. So it's going to put it over here, as you can see. And yeah, we're going to leave it like that. So maybe just over here. There you go. And copy and paste it, because we are going to have a third one as well. And this one is going to be at X 13,139 minus 160 for the Y, and for the Z 4,701, which is going to put him over here, because when we go up, we will need to drag this bad boy down in order to be able to jump up and finish the level. So if I hit the play button now, and if I go over here with the ball and I jump over here and I come close over here, come on, let's move these bad boys. Come on over here. Whoop, 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 whoop. There we go. So now what we need to do is pull this bad boy over here so the lasers don't touch us. There you go. And over here we will have the elevator that's gonna pull us up. And when we go up, then we will be able to interact with the other cube. So there you go. Come on, can I actually pull it? No, I cannot. There you go. And now the lasers cannot do anything to us. But yeah, there you go. So if something is not clear before we proceed, please ask in the comment below, because the next step is to actually create the elevator and wrap up our game. So let us right click over here, blueprint class, actor, so inherits from the actor, and it's going to be BP underscore elevator, elevator. Actually, is it spelled like this? It's like this. I have issues spelling, so don't judge me. Anyways, going back over here, selecting the elevator top root component, we are going to filter for the mesh. So actually static mesh, here it is. Not instance mesh. What the hell is this? Static mesh. Here it is. And we're going to call it, or elevator mesh, elevator mesh. I'm going to make this the default root component. Now over here for the static mesh, we're going to filter for the elevator, SM elevator. Why am I spelling elevator with L-E-V-E? It's L-E-V-A. So there you go. This is our elevator. Now over here for the element, or the material for it, is going to be the stone material. Stone material. Here it is. Stone mat. And this is going to be our elevator. Compile and save that. Now we are going to select it and we are going to attach a box. So over here, box collision. There you go. So this box collision, I'm going to simply call it trigger. And we are going to resize it, of course. Now we are going to set the Z position to 215. And the extent over here, the box extent, 400 for the X, 400 for the Y, and the Z can be 100. So there you go. This is our box collision, and it will detect when, well, the player comes close on it. Simple as that. Now, going here in the event graph, I'm going to delete everything over here, and I'm going to add a couple of variables. We are going to need 1, 2, 3, 4, 5, 6 variables. Did I add 6? We will add them on the go. So over here, the first one is going to be our UI HUD REF, so reference to the UI HUD. The next one, click on it, is going to be speed of platform. The next one is going to be up limit. The next one is going to be the down limit. The next one is going to be is moving. And last but not least, the last one is going to be move up. So the UI HUD is our game HUD, which is simple. We did this already numerous of times. Speed of platform, it's going to be a float. Next, our up limit is also going to be a float. Our down limit is also going to be a float. And is moving and move up are going to be booleans. Now, by default, the speed of platform, I don't know, we can set it at 3 by default, so we can compile and save that. Up limit, we are not going to touch that, or we can, but we will see later, don't worry about that. So basically, you can set it at 3,465. This is the up limit. And the down limit you can set at 2,485. We will see what this is. Now make sure that speed, up limit, and down limit are public variables because we will want to edit them. Well, we will want to edit them on inside of our level directly. So anyways, let's bring back the begin play. What is this? So event begin play. Here it is. So in the begin play, we are going to delay the same reason why we are delaying over here in the interactive block at the top. So the same reason why we are delaying over here the execution. We are delaying 2 seconds. And what we are going to do after that is that we are going to cast to BP player ball. Now, who am I casting? Of course, the player pawn. So get player pawn and plug this bad boy in over here. After that, what I need is to get the reference from the UI HUD. And the UI HUD is inside of the player. So we're going to say get HUD. Here it is, and plug it in over here. So now we have the reference to the UI HUD. We got that from the player. Now, what we are going to do now, select the trigger. So make sure the trigger is selected and right click, and we are going to filter for on component begin overlap. Same thing, we are going to right click and filter for on component end overlap. So on component, actually we didn't select the trigger, so select it, right click on component end overlap. There you go. So when the overlap begins, when we detect collision, we first want to cast, so cast to BP player ball. So casting to the ball the other actor, because we need to detect if we are colliding with the ball. If the ball is on the elevator, then what we are going to do is we are going to get the player controller. Get player controller. There you go. And from here, we are going to enable the input. Here it is. Enable the input and plug this in over here. And from there, we are also going to get our HUD reference, and we are going to show the interaction text. Show the interaction text. This is when the player comes on, when it's on the elevator. Over here, when the overlap ends, however, we are going to again cast to BP player ball, and we are casting the other actor. We do need the player controller again, so copy and paste him over here, and from here we are going to disable the input and plug in the player controller. Now we are also going to get the UI HUD, copy and paste, and this time we are going to hide the interaction text, so hide it. But we are also going to do one more thing, and that is over here we are going to say is moving, and we're going to plug this in, or we are going to say that we are going to check the checkbox, so indicating that we are moving. And over here we're going to say move up is false, and we will see in a second why we are doing it like that. So this is when we collide with the player. Again, this is all self-explanatory. All of this here, I don't have to explain. All of this here, when we, simply check if we collided with the player, this enable the input and show the text that we need to interact. When the player goes away from the elevator, then if that is true, disable the input, hide the text, and is moving is true, and move up is false, which means we are going to move down. But over here, I'm going to right click and I'm going to say action interact. So when we press the interact button, what's going to happen? Well, when we press it, we're going to go inside of a branch. And the condition for that branch is going to be our is moving, and we're going to plug it in over here. If is moving is false, so meaning we're not moving, we are going to say set move up to be true. So if we're not moving, move up is true. And over here, set is moving to be equal to true. There you go. So only if is moving is not true, meaning we are not moving currently, so we are not moving, then we are going to move up, and is moving is true, which means now inside of our tick, so going back in the event tick, we can test this out now. Test it. We can just display how it looks like, because we cannot test it. We cannot move up and down. So I can put the elevator over here, and I'm going to put it in the interactive elements. And the elevator's position X is going to be 10,660. The Y position is going to be negative 190. The Z position is going to be 2485. There you go. Which means here it is. There is the elevator. And I can quickly just test it out. So we can go over here. We will wait a few moments for me to test it out, but it is going to work. So interact. There you go. Come on, moving this cube over here. Wee. There you go. Jumpy, jumpy, jumpy. Come on, move this bad boy over here. There you go. Okay. So now we are on the elevator. If we jump on him, there you go. E to interact. Nothing's going to happen if we interact right now, because if we press E, we pressed E and is moving is now true and move up is true, but we're not doing anything, which means we need to do it over here. So we need to go inside of our tick, inside of the elevator. And what's going to happen over here? We are going to go in a branch. And that branch is going to be controlled by is moving. So going over here, if is moving, if that is true, we are going to go inside of another branch. And for that branch, we're going to use move up. So get the move up. And what's going to happen over here? Well, let's go first. If it's true, if we should move up, we are going to go inside of a branch. And what I need to do is move this a little bit down so that we can see it more clearly. So we're going to go in the branch, and the condition for this branch is going to be, I'm going to double click it and like this. So the condition for this branch, as I said, is going to be, we're going to get the actor location. So get actor location, and we're going to split the pin structure. And what I'm going to do is I am going to make a vector, And the value x and the value y are going to go here, but the value z, we are going to add to it plus float. And the float that we are going to add, and let me just remove this. This goes over here like this. The value that I'm going to add to the z value is going to be the speed of the platform. So I'm going to plug in the speed of the platform. What we need to do to test this out is take the speed, or this calculation over here, the z value plus the speed of the platform, and we need to compare if that is greater than or equal to. So if it's greater than or equal to up limit. So we have our up limit, and I'm going to plug it in over here, and that goes inside of this branch. Why are we using the up limit? Because we are going upwards. So if move up is true, we are not going to allow our z position to be above the up limit. So if it's greater than or equal to the up limit, so if that is true, then we're going to say set is moving to be equal to false. And over here, we're going to say set actor location, not world offset, set actor location. Here it is. This goes over here. Is moving is now false. And over here, if this is false, this goes directly over here, but let me just do it like this so that we can clearly see it, what is happening. Something like this. And from here, this goes over here. Of course, for the z, this needs to go over here. So this is what we are essentially doing. Now, what is this? What the hell is this teacher? I'm confused. Don't cry, man. Do not cry, because I'm gonna show you what it is. In the tick event, if we are moving, if it's true, then we are going to test if we should move up. So we are moving, but are we moving up or down? If move up is true, then we are going to get the current location of the player and create a vector out of it. X and the Y are going to stay the same, but for the Z-axis, because we're moving it up, and we're going to use the Z-axis for that, so we are going to add to the Z-axis the speed of platform. If that new value is greater or equal to the up limit, if that is true, stop moving. If it's false, then go here into the set actor location and set the new location by using the new Z position that we gained from adding to the current value of Z the speed of the platform. This is what we are doing. And as you can assume, if it's false, if move up is false, that means we're going to do the opposite. So we are going to go here in another branch, but we are going to do the opposite. Instead of going up, we are going to go down. So we are going to right click, and I am going to get the actor location. I am going to split the pin structure, and this can go over here. And I'm also going to make a vector. So right click, make vector. And again, X and Y are going to stay the same. The Z axis over here, so I'm going to move this over here. The value of the Z, I'm going to subtract from it a float, and the value that I'm going to subtract is going to be the speed of platform. Now, if this value is less than or equal to, because now we're going downwards, so if this value is less than or equal to the down limit, and this goes over here, bam, and I can move this probably over here like this, the down limit, and it's pretty clear. So we're testing if the current value of over here is less than or equal to the down limit. Now, if that is true, again, set is moving to false, and after that, set actor location, and the location is going to be set by the returning value over here. I'm also going to plug this in over here, and if it's false, again, so if it's false, this still goes over here. Click it like this, click it like this, there you go. So voila, this is what we are doing. Compile and save that. So using the tick event, and based on if we are moving up or down, we are going to move the elevator. Let us test that out. So if I hit the play button, and if I go back over here and interact with this, of course, we don't have to do it right now. So come on over here. There you go. Bam. Bam, 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 bam. There you go. Jumpy, jumpy, jumpy. Come on, bad boy, fall down. There you go. So now pay attention. If I come to the elevator, if I hit the E button, you see he is going up. As soon as I remove away from him, the elevator goes down. Now, how the elevator knows that it should go up to the point over here, if I select the elevator, it goes up to the point 364, and it goes down to 2485. If you pay attention, the down limit is the current Z position of the elevator. You see, the down limit over here that I'm pointing with the arrow is the current position of the Z. If we move up, it will go up to the value 3465. So basically what I did is I, moved the elevator like this and saw up to where I want to move the elevator. And then I set the maximum position or the up limit and the down limit. This is how I calculated the up limit and down limit. That's why I said over here we can leave it to be 0 by default, or we can leave it, or we can then, we can set the value because I knew the value because I already prepared the project, but we can set them at 0. And when you position the elevator in the game, and from there, you can then use the values of the position to actually set that. So again, if it's not clear, if something is not clear when it comes to this over here, just let me know in the comment below so that I can explain it. So let's test the game out one more time. So when I hit the play button, we have the ball, we can move. If we fall down over here, we are losing health. As you can see, we can interact with the cube. So I can just move it like this. Come on, QB, QB, QB. There you go. And jump, 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 jump like a Spider-Man. Go over here. If I fall down, we know what's going to happen. But let's move the cube and not fall down. And actually move the cube like this over here towards us. So, yeah. And now the laser cannot do anything for us. So let's go over here, interact with the elevator, and we can go up. Now, how can we interact with this cube? Well, of course, we need to jump and move it like this. There you go. So interact like this, jump and move it. And now we can jump over here on top, and there we go. Now, basically, as I said, and you see over here, we have E to interact from the cube. So the collider of the cube is this large, so it can catch us. But anyways, you can fix that. That's not important. Also, over here on the top, you can add a flag or whatever you want to do. The ending of the game is up to you. So you can add a flag like level finished. As you already saw, and I showed you that in the beginning, you can move these cubes to these rocks actually to create a different level. So this serves like a template that you can build upon, you can add, expand it, and so on and so forth. So the ending of this game is up to you. You can practice, add new features, and probably share that in the comment below with us so that we can see. Anyways, thank you for watching till the end of this tutorial. It was very nice. It was very entertaining creating it. Hopefully it was nice for you to watch it. I don't know. I mean, until next video, if you like this video, make sure that you like, share, comment, subscribe so that, that will help the algorithm and other people will see it. Yeah, if you like what you see, I have plenty more of this in my Ultimate Game Development Academy. Link will be in the description below. Until then, again, thank you for watching. I will see you guys in the next video.